Hello, everyone. You're welcome, very welcome to today's event. Before we introduce the session today, as always, I'd like to welcome you to check in for today's session. So checking in not only gives you access to information and resources, which are around similar topics that we are running out of the reactor, but as you will know, in this higher ed tech student series, we are running a giveaway. So participants who attend a minimum of 4 events within this series will receive a certification voucher for free. So these are usually valued at around $165, and they're limited to 1 per person for the first 300 people. So to be in with a chance of receiving this, you do need to check in for each event that you attend so we can track that. So the details are on the screen in front of you. I will post them into the chat in just the next couple of minutes as well, so you'll have them there. So I'd like to quickly go through our code of conduct before we kick off today. So this is just a reminder to everyone to be aware of others who are on the call, friendly and patient throughout, and welcoming to everyone who's here. If we do see a difference of understandings in the chat, just to be mindful and respectful of where people are coming from as well. So I'd like to introduce our speaker for today. Dimitri is delivering today's session, and Dimitri is a cloud developer advocate at Microsoft with over 13 years experience. So bringing a wealth of experience with him, we're delighted to be welcoming you back again today, Dimitri. And today's session, as you can see, using Text Analytics for Health to extract insights from COVID papers data set. So this will run over the next 60 minutes, and that's inclusive of any Q&A that you have. While you are muted today, you are welcome to ask questions that you have in the chat. I will be monitoring that throughout, so please do use that as much as you would like to. We are recording this session as well. I hope that you'll have seen that, and it will be made available to watch on demand as well. So I think that's everything from me. Dimitri, I'll hand over to you to get us started.
Thank you, Emma. So thank you for coming today. And as Emma mentioned, please feel free to type any questions or comments in the chat. That would be really helpful for me to know that you are listening and you are following, and that I'm saying something which is interesting. So today we'll talk about using Microsoft Cloud to analyze COVID papers dataset. And this is a good example because it shows you how you can use different cloud technologies, first of all, to solve real-world problem, and how can you put different building blocks in the cloud together to tackle this rather complex problem and arrive to the solution relatively fast. So the main problem looks like this. Since the beginning of COVID pandemic, there have been a lot of papers published on the subject, like medical papers. And there is a data set called Cord19, which collects together all those papers. And by the, I think, February, last time I checked, there was about 400,000 papers in this data set, 200,000 with full text, 400,000 with metadata and abstracts, and all the data is collected centrally in one data set, so it's easy to get access to it. And daily there is about 30,000 new papers added, so it means that there is really a huge amount of information to have. And the person who wants to study and to who is interested in some specific topic, it's very difficult for him to look at all those papers, at this huge amount of information, and make any sense of it. Of course, there are keywords, there are traditional ways to search inside texts. However, that doesn't give you deep dive into the semantics of text. For example, if you are studying the different medications, you might want to know which papers mention specific dosages of which medicines. And being able to do those kind of deep semantic queries is something which would be helpful for scientists who are working with this data set. In addition, it would be interesting to see if we can use modern AI technologies to extract different patterns of treatment for COVID-19, like how those patterns changed over time, for example. So let's see how can we try to do that automatically. And the main idea of this project is to use natural language processing to solve this task. Natural language processing is the area which is being developed now really rapidly because like in the last couple of years, that's the fastest growing area of artificial intelligence, mainly because there is a lot of data to train neural networks on. You know, when you are training neural networks, one of the main problems is where to get the data if you want really to build really powerful models. And with natural language, the answer is well, not simple, but there is really a lot of textual information available, like all internet, all articles and papers being published, Twitter, a lot really textual information. So it would be nice if we can build on top of that information. Of course, labeled data is scarce because it requires manual labeling, but just plain texts, there are many of those. And the idea behind the latest advances in natural language is to use so-called language models. So language models are models which are trained on large volumes of unlabeled text, and which somehow understand how the text is built. Like they understand the structure of language, relationship between words, a lot of things. And then once you train this generic language model, you can train specific models for solving specific tasks. And main tasks which are solved by natural language processing are the following. Like the simplest one is intent classification, when you are given a phrase and you want to classify what this phrase means into one of several predefined categories. It is also like the common problem spam versus no spam, or if you have the for example, the support, user support, you want to classify incoming messages into 5, let's say, predefined categories. That is called intent classification. Slightly more complex task is named entity recognition, when you want to extract specific entities from text, for example, dates or locations. And that is not that easy because, for example, when you say, I want this done the day after tomorrow, this phrase, the day after tomorrow, refers to date time entity. And you can say this date time entity in many different ways. The same goes for location. I was spending my vacation in the city near Paris. The whole thing, city near Paris, would be the reference to location. So it's not as easy as just looking at keywords in the dictionary or something like that. Then another task would be keyword extraction, when you are looking for words which makes more sense, like which contribute more to the semantics of the specific piece of text. Then text summarization, which is to be able to take the long text and produce the short version of it, either by just highlighting the important parts or maybe even by rephrasing. Finally, question answering is when you want to be able to produce specific answers from given text, given some question. And that is very powerful. Those are very powerful models. And the most powerful is open domain question answering, when you, for example, want to build a model which takes the whole Wikipedia and which is able to answer any question from the Wikipedia. And that model is actually quite a complex one. If you are interested a little bit more on this topic, you can drop a question. I'll share the link. I have the blog post on how to train the open domain question answering model on the same data set of papers that I'm talking about now. And if you want to learn about natural language processing in general, we are just releasing, almost as I speak, the new Microsoft Learn module on natural language processing with PyTorch. It's one of the 4 modules in the learning path. There is also a module on computer vision, on audio processing, and general introductory module on PyTorch. So that would be a really good place to start learning NLP if you are not familiar with it. And also like sharing with students and whoever wants to learn PyTorch and how to solve language-specific tasks with PyTorch. So in general, how those language models work. The idea is that if you have a lot of text, unlabeled text, you can predict, like you can try to mask out some words and predict which words should be there. So for example, during holidays, I like to do something with my dog, and you ask the model to predict what is it, like play with your dog, sleep with your dog, fight with your dog, and so on. And by doing so, by predicting missing words, the model tries to capture the context and understand which words go together well and what is the structure of the language in general. So one of the most recent models in NLP is called BERT. And BERT does exactly this. It does a so-called masked language model, which is predicting the next word. And it also has the next sentence prediction model, which is predicting the next sentence. It can predict whether the next sentence would be this one with a certain probability, yes or no. And BERT is quite a huge model. Like the normal BERT contains 345 million parameters. So it's very difficult to train it from scratch. So what normally is done, you train the model, you pre-train the model on the generic language corpus, and then you specialize it on some specific texts. So in our project, the main idea is to use NLP tools, in particular entity extraction. So if you have the original papers dataset, you can extract entities and relations from it. And entities and relations would be like hierarchical. So every paper would contain several entities. Entities would be related. So this is a semi-structured document, not non-relational. And you can store them into a non-relational database, for example, Cosmos DB. Because when you think about databases in the cloud, in Azure, Cosmos DB is the right place to go. And then we would be able to analyze it, to do powerful queries to it, display it using PowerBI. So that I will show you how to do shortly. So when it comes to extracting entities, how can we do that? Well, if we want to do it, we need to train a neural network model. The idea is that there is the library called Hugging Face, which makes it simple to train all kinds of models based on BERT and transformers. But the problem is, as always with data science, the problem is the data set. You need a data set with entities underlined and classified. So if we look for the data set, there is one recent data set on Kaggle, which is called Medical NER, which was developed specifically to solve the same task, like extracting entities from COVID papers dataset. But this dataset is really tiny. Like it contains 300 entity entries, like 300 entities underlined, and only 40 papers. Like it's really, really small. And that is not good because you cannot train powerful model on this small dataset. The second option is generic medical dataset called BC5CDR, which contains 1,500 papers and 5,000 entity entries. That is much better, and it contains only two types of entities, disease and chemicals. So we will see if we can train this, use this for training the language model. Then the question is like which base language model to take. You can take generic BERT, and generic BERT is not specialized to medical texts, and that's why it's not the best idea. Or you can pre-train BERT on medical texts. And luckily, Microsoft Research has already done that. So Microsoft Research took generic BERT and produced the network called PubMed BERT, which is pre-trained on the medical papers from PubMed, which is the well-known resource for sharing medical papers. So the way we do this, we start with BC5CDR dataset. The dataset looks like this. You have for each paper you have abstract and title. Those first part is abstract and title, and then it contains the list of entities, position of the entity inside the text, then the type of entity, and also mapping to ontology, which is really cool because it's nice to be able to map entities also to some well-known dictionary. Because, for example, you can say COVID-19 in different terms. You can say SARS-CoV-2 and you can say COVID-19, and that would refer to the same disease. So it's nice to be able to map those to one entity. So we have this data set, and the way we solve named entity recognition problem is to solve it as token classification problem. So the idea of token classification, like whenever we deal with text, we tokenize it. We split it into tokens. Roughly each token would be one word, but not always. So sometimes we will split one word into several tokens. For example, if it's a chemical, it's sometimes useful to separate it into parts. And entity recognition would mean that for each token, we map it to the corresponding entity type. And normally, it works well if we don't just map it to entity type, but we also specify whether it's a beginning of entity or continuation of entity. So, for example, this first three words is a disease, and we map it to B, Ds, IDs, and IDs. So BDs means it's beginning of entity of disease type, and then this is continuation. The same for lithium carbonate, beginning of entity, continuation of entity. So in continuation, I stands for inner, so it's the inner entity, and so on. O means other, so none of the entity types. So the way we train it is to use PubMed-BERT. So PubMed-BERT was produced using a technique called mixed domain pre-training. So it took the generic texts from the public sources. It enriched the vocabulary using PubMed, and then starting from generic BERT, which was trained on public sources, it produced biomedical BERT, which we used. So to use it, it's pretty simple because Hugging Face library, it's built in a very open way. It contains the repository of all contributed networks. So you can just, using Hugging Face transformers, you can say, I want to get the model with this name, Microsoft/Biomed NLP PubMed-BERT based on case abstract, which means the model trained on abstracts. Then we take the tokenizer from this model. Tokenizer for medical texts, as I mentioned, might be different from the generic BERT tokenizer. And then we build the model called BERT for token classification, specifying the number of tags. So the way Hugging Face works is that you will have the top part of the network pre-trained, but you need to train the final layers on your dataset. So just briefly to show you how we have done this, I have used Azure Machine Learning. So in Azure Machine Learning, there are very different ways to use Azure Machine Learning. I've used the simplest one, notebooks. So we can go to Azure Machine Learning workspace, then launch Studio. We'll end up in the studio like this, and then we go to notebooks. And here is my notebook for training PubMed-BERT. So just very briefly, I will show you how it looks. Here is my original data set, which is similar to the one that I have shown on the slide. Then I do some Python data manipulation to extract entities and end up with this encoding. As I mentioned, for each entity, for each token, we have the class, disease, or chemical. And so we end up with this list. And then we just create data sets in the format suitable to be passed to Hugging Face. And for training, we use GPU, of course, because that is faster. And we start training using trainer. That is taken from the official documentation of Hugging Face, so it's pretty much common code. And once we train this, we can take some text and apply the network to it, and here is the result. You see a lot of 2s, meaning that 2 is probably the number of class for other. And I can actually print the entities which I have extracted. And you can see that, for example, hydroxychloroquine, the very common medicine for treating COVID, it's actually represented by 3 tokens, and it has been correctly identified as chemical. And HCQ, which is the short for hydroxychloroquine, has also been correctly identified as chemical. Chloroquine is chemical, and then what else? Amino quinoline is a chemical, and so on. There are some problems because this aminoquinoline is classified as ICH, but not the beginning CH, which is probably a mistake, but that's how it is. It has been trained on relatively small data set, so there are some mistakes. So that's how the training works. And if I show you the result, here is the result. You can see that this is the real abstract from court papers dataset. And you can see that some very important terms for us, like COVID-19, has not been recognized at all because the dataset did not contain this term. That is all the dataset, which was pre-COVID times. So it did not contain this disease. And that is not very good. Probably we need to do something with it by adding this term or manually adding some recent abstracts to it, or adding another data set, which I mentioned, which is small. But luckily, once we have trained this, I have also discovered that there is a pre-trained model released by Microsoft called Text Analytics for Health. So this PubMed BERT publication is dated like maybe a little bit more than half a year ago, probably less than a year ago, maybe like 9 months ago. And already now we have the service which works in the cloud, and you can use it to apply this PubMed BERT model to solve medical tasks, text analytics tasks with medical texts. So this service is currently in preview, and it is so-called gated service. So you need to apply to get access to it. And by making it gated, we make sure that it's not being used in sensitive scenarios and that it's not being used in production. So right now, because it's the preview, it's not permitted to use this service in production, just for analysis and some kind of study research tasks. So it supports this Text Analytics for Health, supports 4 things. It supports named entity recognition, relation extraction, entity linking, and negation. So what does it mean? It means that given the text, we find all entities in it, and each entity has the type. It also has the ontology link, so it can be related to some well-known medical ontology. And also, if the entity is mentioned in the negative context, for example, here it says it's not well established against SARS-CoV-2, this entity is marked as negated. So it means that it's in the negative context. And also it extracts relations. So for example, here it says sore throat, which is a symptom, appeared at this time, and it has the relation time of condition. So how to use that Text Analytics for Health? That's pretty simple. We have the SDK. We need to install specific version, like beta version of the SDK, because it's in preview, so it's not available in the generic version. Then we create the client specifying also the version of the API to use. And then we just do the call. We do the call, and we get the list of entities as the result. So for example, with this phrase, we'll get something like this. You see, it's a list of healthcare entities. For example, this 300 milligrams is represented by this healthcare entity object. You see the text is 300 milligrams, category is dosage. Then there is also like related entities. So for example, here favipiravir, category medication name, and this is the ontology link. This is the ontology ID in the upper medical ontology. So that's how it looks. It also extracts relations. So for example, here we have 300 milligrams is a dosage of favipiravir, which is correct. And then daily, it's a frequency of medication. So you can see that there are a lot of nice things that the service extracts. Now, what we want to do, we want to analyze the whole data set of paper abstracts. How can we do that? We have 400,000 papers. If we analyze them sequentially, like one by one, it would take 12 hours, roughly, maybe more. So what I wanted to do, I wanted to speed this up. And to speed this up, we can, because it's a very simple case, we just need to do a parallel sweep, like execute the process on several machines in parallel. We can use technologies like just a VM pool, or we can use Azure Batch, but all that is more complex than using, again, Azure Machine Learning. So Azure Machine Learning contains, so here is the everything which is in Azure Machine Learning. It contains compute clusters, and you can schedule experiments on the cluster. So what we can do, we can, first of all, we define the data set with the paper abstracts, and then we schedule the job on the cluster, but not the machine learning job, which is typical like for Azure Machine Learning, but we schedule the job to run cognitive services. And that can be also done. So Azure Machine Learning you can use in several ways. You can start the job from Python SDK. You can also start the job from command line. And that is the way I preferred to try in this project. So first of all, we define the data set. So the way it's done, we write the dataset description in YAML file. So I will name it metacode, and it will be a local file called metadata CSV, which is the way that all abstracts are stored. It's a CSV file, very large CSV file. Well, not very large. It's like something like 0.5 gigabyte or something. And then we just see AZML data create, and which uploads this data set to Azure Machine Learning. As easy as that. Then to run things in the cluster, we need to create an environment. In my case, I need this Azure Machine Learning SDK to be available. And to do that, I need to define the environment, which includes this as the dependency. So I say I want to define an environment which starts with this Docker image and adds this config file, conda config file, and then I execute command azml environment create, which creates the environment. So let me take the question from the chat. Can this Text Analytics for Health service be used by university students as a part of their postgraduate data science degree? Yeah, definitely. Well, not definitely, but I would say yes. But I cannot guarantee that because when it's gated service, you need to apply for the usage. And to apply for the usage, you fill in the specific form. And the reference to the form would be like in the slides, or you can just look, you can look for Text Analytics for Health, and you will find easily the page. And you will say, explain how are you planning to using the service. So you would say, I am planning to use the service to do some research on scientific literature, and that would be, I think, very legally correct usage of the service. And while it's in preview, it's even free, so you would not need any kind of cloud money, cloud resources, paid cloud resources to use it. So you just apply to it, and the only thing you would need Azure subscription, and that any student can get for free using Azure for Students. So that should be pretty straightforward. There might be some complications. For example, like the gated service might say we don't want to give access to free subscription. I don't know, but yeah, it's worth trying. And if you have any problems, you can probably get in touch with me, and we'll see what we can do. Okay, so let's continue. So once we define the environment, we submit so-called sweep job experiment. So the idea is that we will take this data set. We have already defined this metadata CSV data set, and then we'll schedule a parallel experiment on the cluster, and we'll store the results in some central location. So for example, in the database, and I will talk about which database in a moment. So the idea of this sweep job, normally it's done to do hyperparameter optimization. So you would execute the same experiment with different parameters. So here I would say I want to execute the same experiment with parameter 0 or 1. If I want to split it into two machines. If I want it to be 4 machines, I would say 0, 1, 2, 3. And then this is the commands to execute. I would say the number of nodes is 2, and the number is search space number. So for each copy of the script, we would get the different number parameter. And the Python script would take this, it would read the data set, and then it would just iterate through all items and process only those which are divisible by, like, which give the remainder divided by number of nodes, which remainder should be equal to number. So in our case, every second entry. So that's as simple as that. I run this, I wait for it to complete. Like on 2 machines, it probably would finish in 6 hours. In my case, I used 2 for demo purposes, and I didn't mind waiting for a little bit longer. But you can scale it to any number of nodes, and that should be pretty linear because it's a very simple parallel sweep. And as a result, we get a structure similar to this one. So for each paper, like, we have the ID of the paper, we have like title, authors, and so on, and then we have the list of entities, and we have the list of relations. So this is inherently hierarchical. So it's not easy to store it in a relational database. Well, not very complex, but still, like, it's those documents are easier to be stored in NoSQL database. And the official NoSQL database for Microsoft is called Cosmos DB. Cosmos DB is like very cool technology because it contains several different database types in itself. It supports graph database, like tables, which are kind of non-schemaless tables similar to Azure tables. It can be like document database for storing JSON documents. And all that can be scaled to different nodes, to different regions, using different strategies. So it's very flexible and can be used like for very different tasks. Our task is very simple. We just want to store JSON documents and query. So what I did, in this script, I put the data directly into Cosmos DB database. So at the end, I ended up with the Cosmos DB database having all the papers. So in Azure portal, it looks like this. I have this my CoVDB database, and you can here there is a thing called Data Explorer. So right in the Azure portal, we should see this is my dataset database, and it has the collection called papers. And in papers, we can go to items, and here are all the papers. Like, you can click on any of those, and you can see the JSON document that corresponds to it. Title, authors, journal, and then entities, and at the end, relations. Nice. Now, what we can do with this? Let me go here. We can do queries. Let me, for example, take this query from here, and I'm reverse engineering the slides. And I would say new, I want new SQL query. And here is my query here. And I want to run it. So what I'm doing with this query, I'm saying I want to select from papers, and I want to join relations. So join is not the same as SQL as join in relational database. Join allows me to kind of flatten the structure. So in my case, in each paper, I have several relations, but I can flatten that into a plain table of relations. So that's what join does here. So I flatten it, and then I say I want the relation type to be dosage of medication, and I want the medication to contain hydro, meaning hydroxychloroquine. And I want to select the title of the paper and the dosage. Source text means the other part of the relation. So, and here I get all the list of papers which mention different dosages of hydroxychloroquine. You see, I can do very specific query. Like, if I am a medical professional who looks for hydroxychloroquine treatment, I just do this query and I get immediately all papers which I need. Very powerful. However, like, medical professionals probably would not do that because they wouldn't know SQL. And we want to expose this data to them using some visual tool. And this visual tool can be PowerBI. PowerBI is the technology for data visualization. it contains like a set of tools. It has PowerBI Desktop, which is the tool for creating dashboards on your desktop. And then you can share the dashboard into Power BI service in the cloud, and everybody would be able to see this those dashboards in the cloud. And then Power BI Mobile allows you to get access to the same set of dashboards on mobile. So in my case, because I need to design the dashboard, I need to run Power BI Desktop. And Power BI Desktop has access to different data sources. In my case, I have all the data sitting in the cloud and Cosmos DB. And naturally, I can just say, I want the access to Cosmos DB. Sorry, it takes a couple of seconds to start, and I forgot to do it before the presentation. Sorry about that. So I'm opening existing dashboards, but you can meanwhile see that there are a lot of different tools for creating different visualizations here in Power BI. But what I have here, I have this dashboard with all entities and relations. So for example, here on the left, I have entity types. And for example, I want to see different medications. So I can say entity type is medication name. And on the right, it would reflect automatically the medication, the entities of this time, meaning medications. So you see here, hydroxychloroquine is the most popular. This is sorted by descending count number of entries. So hydroxychloroquine is the most popular one. And HCQ is the second popular one, and HCQ stands for hydroxychloroquine, and that is clear because they have the same ontology ID. You see here, we can easily see that that refers to the same entity. And then remdesivir, chloroquine, tocilizumab, and so on. Different vitamin D, different popular medicines for treating COVID. And that goes for entities. Then if we switch here to relations, I can do the query which I showed you previously in SQL, like how to find papers which mention different dosages of hydroxychloroquine. So I can go to the relation type dosage of medication. And here we have like all the different medications and the dosages. And here we can filter on this document target by clicking filter, and we will end up having the results that I need. So in this tool, I did not go deeper, like it will not show you the specific papers, but that can be added into this model, and we can create kind of interactive visualization tool for medical professional, which is I think really nice way to do it. And to create this dashboard, you just need, like I spent half an hour doing that. And then what would be more interesting is not just to like get access to the data, but figure out some interesting insights from it. And normally, if you want to play with data, you would use Python, right? Jupyter notebooks, because they would allow you to like do whatever manipulations you want. But like in our case, I have all the data in JSON, so I can of course write a Python script which would digest this JSON and give me the result I want. But on the other hand, it would be easier if I give the first processing step to the database. Once I have this Cosmos DB, I can already do powerful queries. So for example, if I want to get like all medications, the most frequently used medications, I can do that in SQL, in this specific Cosmos DB SQL. But further processing can be done in Python. So it would be nice to combine those two approaches. And in fact, that is quite common scenario. In Cosmos DB, if I go back to Cosmos DB here, I have the notion of notebooks. I'm sorry. Notebooks, let me open a notebook here. So nice thing about those notebooks is that they combine Cosmos DB with Jupyter kernel. So here, right here, you can write SQL query. And I want, for example, this SQL query to output the result into MEDS data frame. So it supports tight integration with pandas. Pandas is the right way to manipulate tabular data in Python. So here, the result of the SQL query is normally would be a table. And it's easy to store this result in the Python data frame. So I do this query. This query selects the title of paper, entity, and whether this entity is negated, together with its ontology ID. It tries to find the UMLS ontology ID. So I end up with a table like this, like entity, ontology ID, sometimes which it would be like undefined, and publishing time. And then I can do like whatever data exploration I want. So for example, here, what I can do, I can select all the entities grouped by ontology ID so that I eliminate like duplicate naming of medicines. And I can sort them by popularity and also calculate this kind of negativity index, like how often it was mentioned in the negative context. It doesn't mean that this medicine is bad. You cannot draw quick conclusions from this, but it would still give you like the estimate of what to look for. So once you have this table, you can select the most popular medicines and try to group this by time. So here I group it by month, and I end up with a table like this. This is like the January 2020, February 2020, and for each medicine I have the number of mentions. And then you can plot this. So for example, here you can see on the graph how the number of mentions of the corresponding medicine changed over time. So you can see that for hydroxychloroquine, it was like mostly mentioned in like April 2020, and then number of mentions started to drop. And this is absolute number of mentions, this not taking into account the fact that number of papers declined, meaning that it's really like if you take the percentage, it would be even more, even faster drop. While more modern things like vitamin D, this popularity like increased, and like things like favipiravir, which is the more recent way of treatment, it also increased. So that is pretty nice to be able to produce automatic insight like that. So we can do that like absolutely not reading anything, just by doing data analysis. And another interesting thing to do would be to build graphs like this, like relations between different terms. So for example, we can say different treatments for different diseases. For example, for COVID-19, you see prevention plays an important role, but it is the same for all infections. Like for all infections, prevention is quite often discussed. And we can compare like how often different preventive measures are mentioned, like masks, mechanical ventilation, and so on. The same goes for different medicines. Like for COVID-19, you can see how different medicines were mentioned. For example, hydroxychloroquine is very popular in relation to COVID, but for other infections, it's not as much used because it's very specific drug. And finally, we can also look for terms co-occurrence. For example, hydroxychloroquine often occurs together with azithromycin, which is a popular combination. So we can see this combination by in our analysis as well. So that's I think that was the demonstration, the main demonstration from me. The main goal of this was like threefold. First of all, I want to show and convince you that text mining for medical text can be a very valuable resource for gaining insights into large corpuses of text. And this can be done in the scalable manner using cloud technologies. So in this demonstration, we put together different cloud technologies, and all of them worked like together smoothly to produce the result. And the good thing about the cloud is that you can combine cloud as a simple building blocks. Like if you wanted to do all of that on your own home computer, that would be much more difficult. Like you would spend a lot of time like setting up the environment, like it would be difficult scaling. And here you have a lot of existing technologies which are already tailored for solving specific tasks. And That is the beauty of the cloud. And finally, I wanted you to have a look at Text Analytics for Health and into like in general to have the small dive into NLP technologies, because NLP can prove useful in very many scenarios. And some NLP tasks are already pre-trained and available as cognitive services. For example, if it's not a health domain, you have the generic keyword extractor, you have generic like entity classification service. So some of the tasks, non-medical, you can also automate using cognitive services in a similar manner. But if you have something really specific to some other problem domain, like you want to extract something in the purely in chemistry, in biology, in this case, you would need some label data sets and training your own custom models. But you have seen that that is also quite easy to do on Azure and with modern libraries like Hugging Face transformers. That is it from my part. If you have any questions, please feel free to ask them now in the chat. If you will have any questions in the future, or you want some specific details about this project, or you want some specific links or guidance, feel free to get in touch with me. On my website, I have contact information on the right, and that's easy to find me in Twitter, on Facebook, and so on. So while you are thinking on the questions, I will copy paste some links from this talk into the chat. First of all, there is not exactly this deck, but very similar deck available online. It's a little bit shorter, but very similar to this one. Here is the link to PyTorch learning path. Actually, that might not be the best one. The best one would be the one that I will type now. Let me just try to remember it correctly. Yeah, this one. This one goes to the Microsoft Learn. And right here, if you go into specific like units, each unit would be essentially a Jupyter notebook, which you can run right here for free on the GPU-enabled compute. And you can try all examples. It contains like, it mostly focused on text classification, but the main tools are all considered here. So there is a question whether you can use this tool for non-COVID healthcare corpora, and that's definitely, the answer is definitely yes, because it was trained on PubMed dataset, and PubMed is generic dataset of medical papers.
Brilliant, Dimitri. Thank you so much for sharing all of those links for another excellent session. I would just like to remind everyone before we finish today's session and wrap up to make sure that you're checking in for the events that you're attending. So checking in will enter you for the certification voucher giveaway that we are running as part of this series. So what I will do again is just paste the details into the chat. So checking in enables us to be able to see which events that you're attending. And if you are able to be part of the giveaway. So just make sure that you are doing that. Okay, I don't see any more questions coming through, but I'd like to thank everyone for attending today's session. I really hope to see you back again next week. So next week's session is connect everything to the cloud with IoT. and is being delivered by Jim Bennett. So please do come along to that session. Hope to see you back again there. And Dimitri, thank you so much for delivering today's session. It's been such a pleasure to have you back.
Thank you.
Just had a question there. When will the video be posted? Good question. So hopefully be posted by the end of this week. If not, it will be early next week. And that goes on to our series page. So let me just drop a link into the chat where you'll find it. All previous sessions are available there to watch as well. So the last 3 episodes that we've run. Okay. I think that's everything. Give people some time back today, but thank you once again, and really hope to see everyone back again soon.